Hello, class. This is Professor Rourke here to hopefully give you some help if needed on some of the new differentiation rules. So I know things move quick. We just took the test on all of these lovely rules, out of what a derivative even is, rather. And now all of a sudden we're just jumping right in into 3.1, which covers more of like the idea of the derivative and mostly like focusing on the power rule. And then 3.2 dives right into the product and quotient rule. So let's go ahead and take a look real quick at some of the questions that I think caused some of the issue, beginning with question number 9 on the 3.2 Webassign. So 3.2 number 9 says that my numbers could be slightly different, but same vibes, okay? Suppose that f of 4 equals 2, g of 4 equals 3. The derivative at f at 4 is -5, and the derivative of g at 4 is 4. Okay, so a lot of information here. And then it says find the derivative at h of 4. But for each of these, h represents something slightly different, right? So for instance, a says that h is 4 times f of x plus 3 times g of x. So for a, all we need to do is, this is just a constant multiple rule, is where we can just, okay, if we have 4 times f of x and we have to find the derivative of that, that would just become 4 times the derivative of f at 4, okay? And then same vibes, plus 3 times g of x, the derivative of that would just be 3 times the derivative of g at x, which again, in this problem, they want us to find 4. So we can do that, not too terribly awful for part A, okay? And then they sort of kind of progress, I feel like, in the difficulty level as we move down. Okay, so for this particular part A, again, your numbers could be slightly different, but same idea. So this become 4 times -5 plus 3 times 4, which would be like -20 plus 12, which is -8. Okay, hooray. Great. Okay, next part B, says h of x is now f of x times g of x. Okay, so now they're getting into the product rule. And hopefully that makes sense just looking at that. I can see that they're being multiplied together. So if I wanted to find the derivative of h of x, I would need to take f of x times the derivative of g of x plus g of x times the derivative of f of x. Now, there are a couple, you have a little more freedom in the product rule than you do for the quotient rule. Like in theory, you could have wrote these as the derivative of g of x times f of x plus derivative of f of x times g of x. Like if you just had these sort of like these two products just sort of written in the opposite order, or also vice versa. You could even like rate the first one, g of x plus the derivative of x first, right? Like because commutative and multiplication and addition are commutative, then it's okay if you have it a couple of different ways. We're going to get the same thing in the long run. Okay, so like for instance, if we're talking about at 4 here, then we could take the function f of x at 4. Let me go ahead and fill this in. It'd be like f of 4 times the derivative of g at 4 plus g of 4 times the derivative of f at 4. So slightly more complicated, right? But again, as long as you sort of hopefully keep track of what the problem is asking you, hopefully it doesn't get too terrible. Okay, so f of 4 is 2. The derivative at g of 4 is 4 plus g of 4 is 3 times the derivative of f at 4, which is -5. Okay, so for this problem, we would just have 8 essentially minus 15, which is -7. Hooray! Okay, next type of problem. Again, they're slowly kind of getting increasing in difficulty. Is f of x divided by g of x. So now we're talking about quotient rule, right? Does that hopefully make sense? So quotient rule is a little bit of a doozy. It is, I'm not gonna lie. just to kind of, it's a lot of pieces, okay? So if h of x is f of x divided by g of x, and we want to find the derivative now for part C, this is the same thing. We would have to say there's not as much wiggle room here in terms of how you can write them like there was for B in the product rule. Okay, so it always has to start out um, the bottom times the derivative of the top minus the top times the derivative of the bottom. Now again, these products, you could write them in either order. Like in theory, for the first term, we could write derivative f of x times g of x, but we can't, subtraction's not the same, right? Subtraction is not commutative. So I'm just gonna be careful about the quotient rule in particular. Okay, so now we're gonna go ahead and do the same thing, but at 4, okay? So I'm talking about finding g of 4, which is 3 times the derivative of f at 4, which is -5, minus f of 4, which is 2, times the derivative of g at 4, which is 4, and then it's all divided by g of 4 squared, so we're talking like 3 squared. Okay, so now I'll simplify this, so it'd be like -15 minus 8 in the numerator divided by 9 in the denominator. That's kind of gross, but that's okay. It'd be like -23 over 9. Like, okay. So sometimes quotient rule doesn't really come out maybe the kindest, but that's okay. It's just, you know what it is. It is what it is. So hopefully that sort of makes sense, what we're doing there. Okay. And then next we have quite a can of worms. There says h of x is g of x divided by f of x plus g of x. Okay, so at first, like it doesn't look that much different, I feel like, than C, but there's a couple of sneaky parts in here. So let me go ahead and clear what we have so far. Okay, and then let's think about this. Okay, so now it essentially the only difference is that instead of just having a single function, we have like this f of x plus g of x. So to begin the quotient rule, okay, because actually let me pause real quick and make sure this makes sense. This is a quotient rule problem, okay? That is the overarching theme for D here, is there's one function in the numerator, and then in the denominator, it's like two functions being added together, but those are all just inside of one fraction. So no matter what, we're doing the quotient rule. We might have to do a couple things in between, but mostly it's just the quotient rule. Okay, so to start out with, I'm going to go ahead and say whatever the denominator is, which in this case is f of x plus g of x, right? Times the derivative of the numerator, derivative of g of x is just exactly as it sounds, the derivative of g of x, minus, now we're going to bring up, I say the numerator, which is g of x, times the derivative of the denominator. And it is just f of x plus g of x. So I can take the derivative of them separately and just say, okay, that's the derivative of f of x plus the derivative of g of x. If in theory those were multiplied together, it would be a little bit more rude, because then we would have to actually use like a product rule within the quotient rule, because this is still overarching a quotient rule. But if f of x and g of x were being multiplied together, to find the derivative of that numerator, we would have to, or denominator, again, I'm just making this problem a little bit more, in theory, more difficult talking about it. We would have to use the product rule. So I hope that makes sense. But if two functions are being added together, we don't need to bust out. There's no like crazy complicated sum rule or anything. We just take the derivative of f(x) plus the derivative of g of x. Okay, so let's go ahead and try this with evaluated at 4, because again, I know it's a bit much here. It kind of hurts my brain, I'm not gonna lie, just thinking about all these numbers. So we have f of 4, okay, which is 2, plus g of 4, which is 3, times the derivative of g at 4, which is 4, minus g of 4, which is 3, again, times the derivative of f at 4, which is -5, plus the derivative at g of 4, which is 4. Eeh, I know. And then it's all divided by, oops, sorry, I don't think I put that squared there to begin with, f of x. So f of 4, which is 2, plus g of 4, which is 3, and I would have to square that. once I simplify it a little bit. So it's a bit much, it really is. But for instance, this is really just like 5 times 4 minus 3 times -1, all divided by 5 squared, which would come out to be 20 plus 3 divided by 25. So 23 over 25. So again, not like the best numbers, but kind of expect that and when quotient rule comes up, because it can get a little bit ugly. Okay, so I hope these again made sense. Just this number 9, they can hurt because not only do you have to really sort of feel comfortable with the product rule and the quotient rule, but when they sort of meld these pieces together, it can get more challenging. And then just like checking to make sure you have the right numbers plugged in from what they gave you, that can also be tricky. Okay, so in a similar vein of thinking, we have question number 10. And in 10, it says the graphs of functions f and g are shown in the figure. So we have a lovely graph. And then we have f is this lovely sharp looking function that's blue. It looks like it's sort of like decreasing. And then there's like a corner and it goes up and then it comes back down. Another corner goes down. And then g is just sort of hanging out as well. It looks more like an absolute value function where it's a green line and just sort of decreases down to 2 and then back up. Okay, fine. Um, we could, if we had to, go through and pick some points out, right? We could do that. But let's see what lovely can of worms they're going to have us answer for these questions. So for this one, it says, underneath the graphs, let u of x equal f of x times g of x, and v of x equals f of x times g of x. So I think they're going to make us, not only get some values from this problem, but also like calculate some slopes and product rule and all kinds of things. Okay. All right. So first things first, A, it says find the derivative of u at 1. Okay. And then up top, it says again, u of x is f of x times g of x. So let's think. To find the derivative at u, we would need to say that we're going to have f of x times the derivative of g at x plus g of x times the derivative of f of x. And then it gets more fun because then we're going to evaluate this at 1. Okay, so what we're really talking about is saying f of 1 times the derivative of g at 1 plus g of 1 times the derivative of f at 1. And how are we going to get these numbers? We're going to use the graph. Okay, so let's see what's happening. Really, this first part A is all centered around 1. Okay, so first things first, it looks like we need f of 1. So f was the blue line, and if we go and we look at the graph and then we locate what f of 1 is, and I'm just going to write this off to the side to hopefully make sure this is really almost the same as the last problem, just a little bit more a little more pain because we have to go into the graph to find it. Okay, so f of 1 is 2. Okay, I'm also going to need to find later on the derivative at f of 1 at 2. So let's talk about it now, even though if I was looking at my product rule, next up, I would want to find the derivative of g at 1, but I'm just going to focus on what f right now, okay, because that's the problem we're focusing on. Can we find the derivative of f at 1? Well, yes, you might be like, well, wait a minute. This is a line, which means that the slope is constant. So I really have the slope is like the first time we see the derivative. We just don't call it the derivative because it's just a slope, right? The slope is always constant in a line, but it just rise over run. It's just that the derivative we can use for any function, not just a line. But really, all of these are just line segments with different slopes. And so really, when we talk about to find the derivative, we just are talking about what's the slope. Okay, so the slope at 1 is, again, constant, it's a flat line, and it looks like it's going up 2 over 1. So the derivative at f of 1 is just 2. 2 over 1, which is 2. Okay, I'm going to do the same thing for g while I'm here. I'm just going to get all of my ducks in a row. Okay, g of 1 is 1. Okay, so if I look at where the function for g is, I look where x equals 1, the y value is 1, g of 1 is 1. Okay, and then I want to find the derivative at 1, and it's the same vibes as what we did before. The derivative at g of 1 is just the slope of the line because it's a line. So it's a constant slope. And it looks like the slope of this green line at 1 is down 1 over 1, down 1 over 1. So that means my derivative at g of 1 is -1. Okay, so the reason this is a little painful is because not only do we have to, remember the product rule, which is a little bit much, but we also have to remember the lovely finding like this, the derivative is the thing, finding the slope. We got to find the slope of these lines, and then we have to make sure then we keep everything together of what we're even doing here. Okay, so f of 1 was 2, derivative at g of 1 was -1, plus g of 1, which was 1, times the derivative at f of 1, which is 2. So it comes down to be -2 plus 2. Look at that. So it's just going to be 0. Thank you. That's great. All right, let's try this again. Okay, another version of practice. The next question says the derivative at v of 5. Okay, and this time they tell us that v is f of x divided by g of x. Great. So to find the derivative at v of 5, if v of x again is a quotient, right? So I'm talking about finding g of 6 times the derivative of f. Well, I won't even add in the numbers yet. G of x times the derivative of f of x minus f of x times the derivative of g of x, all divided by g of x squared. Okay, so let's go ahead and find the values that we need. Same vibes as before. So let's focus on first, pick g, just because g comes technically first in my formula here. G of 5 is 2. Great. What is the derivative at g of 5? Well, let's see here. It's a line, and I could find the slope of this line if I try to focus on some good points that it happens to go between. Like if I'm looking to the left at x equals 4, that doesn't look great. X equals 3 doesn't look great, but x equals 2, that's a good one. Okay, that's a nice clear point. There's a point 2, 0, and the other point is 5, 2. So I calculate the slope to get between the 2 points. It's up 2 over 1, 2, 3, 2 over 3. Great. That my derivative at g of 5 is 2 over 3. And then same vibes for f. Okay, so f of 5 looks to be at 3. And then it says the derivative at f of 5, what would that be? Let's see here. I'm going to look again for another good point. I see one. I have one point's at 5, 3. That was the one I just found. But the other good point, it looks like to be at 2, 4. So it looks like it's going down 1 over 3. So got some fractions going on with the slope. Thank you. Stephen, God, so kind. Okay, so let's go ahead and try this out. So the derivative at v of 5 would be g of 5, which is 2, times the derivative at f of 5, which is -1/3, minus, the negatives can get a little funky, f of 5, which is 3, times the derivative of g of 5, which is 2/3. And then this is all divided by g of x squared, which is 2 squared. All right, let's simplify this up a little bit. This would be like -2/3 minus, it's a little growth. So I'm just going to keep this as 6/3 for right now, which I know sounds weird, but hopefully it makes sense in a minute. Because I'm going to simplify it. So if I have -2/3 minus 6/3 all divided by 4, there's a few things we can do here. One option would be to put together -2/3 and 6/3 to make, let's think, that would be -8/3. And then this is divided by 4, which is the same thing as -8/3 times 1 over 4, which if we simplify by canceling out some common factors here, it all would come down to be -2/3. Look at that. That's great. But you could also like do some weird stuff. You could like maybe multiply by like clear the fractions out, and say -2, like, by multiplying everything by a 3, and you would still get the same thing as -2/3. But really, it's kind of up to you, whatever you so desire. Okay, so this problem, these questions ran on a little bit longer than I intended. I did not intend the video to make the last this long, but I know it's a little bit, they're a little bit tricky. So hopefully this makes sense between 9 and 10. They are a bit painful. I'm not gonna lie. Some of these derivatives, like the rules are fine. It's not the rules necessarily that cause the problem. It's problems like these that make it not only like the rules, but then like up a level, right? So like where we have to sort of like mix and match, or you have like a um then D for the first one, we had like a two functions being added within the quotient rule, right? Or 10 where we had to like find, yes, we have the product rule and the quotient rule, but we have to also look at the graphs to find the slopes and then bring it back in. So it's just a lot to kind of keep track of in our brains, and it can sort of be overwhelming that way. But I hope this was helpful, even if it was a bit long. I'll add some timestamps since I'm still talking, and keep me posted however I can help. Okay, thanks.